Hey everyone, and welcome. Today, we're going to pull back the curtain on something that's at the very heart of JavaScript. We're going to demystify the execution context and really understand how your code actually comes to life.
So you spend all this time writing clean, elegant, human-readable JavaScript, but have you ever just stopped and wondered, how does a computer, a machine that only thinks in ones and zeros, actually understand what you're telling it to do?
Well, the secret is that there's this powerful middleman, a translator, working tirelessly behind the scenes every single time you run a piece of code.
And that translator, it's called the JavaScript engine. It's this incredible program whose entire job is to take your JavaScript and convert it into machine code the computer can execute. You've definitely heard of the big ones, right? V8 is the powerhouse behind Chrome and Node.js, Firefox has its own called SpiderMonkey, and Safari uses JavaScript Core.
You know, these modern engines are ridiculously smart. They use a technique called just-in-time compilation, or JIT for short. And what's so cool about this is that it gives you the best of both worlds. You get the fast startup of an interpreter that reads code line by line, but you also get the raw speed of a compiler. It actually finds the hotspots in your code, the parts that run over and over, and optimizes them on the fly for a massive performance boost.
So, to really dig into what's happening inside that engine, we need to zero in on this one absolutely crucial idea. Everything in JavaScript happens inside the execution context.
So what in the world is an execution context? Well, the official definition can get pretty technical, but a much easier way to think about it is as an abstract environment, basically a container or a big box where all your code lives and gets executed.
And every one of these boxes has two main parts. First, there's the memory component. This is where all your variables and functions get stored as key-value pairs. Think of it like a dictionary. And then you have the code component, or the thread of execution. This is the part that actually goes through your code, one line at a time, and makes things happen.
Now here's a super important detail. Creating this box isn't an instant process. It happens in two distinct phases. First is the creation phase. Here, the engine just scans your code and sets aside memory for all your variables and functions. No code is actually run yet. Then comes the execution phase, where the engine goes through line by line and actually executes it all.
So, why does this two-phase system matter so much? Because it is the absolute key to understanding a JavaScript behavior that trips up developers all the time. Hoisting. Let's see exactly how this works.
Okay, so take a look at this simple code. We're trying to log the topic variable before we actually declare and assign it. Now, during that first creation phase, the engine scans this code, it sees var topic, and it says, okay, I need to allocate some memory for this thing. So it creates a spot in memory for topic and gives it a special placeholder value, undefined. Okay, now we move into the execution phase. The engine hits that very first line, console.log topic. It looks up topic in its memory, and what does it find? It finds that placeholder value, undefined. So that's exactly what gets printed. It's only after that line runs that the engine gets to the assignment, topic equals JavaScript, and finally updates the value. And that, right there, is hoisting in a nutshell.
But of course, our code is rarely just one big script, right? It's filled with functions. And whenever a function gets called, it creates its own execution context. So how in the world does the engine keep track of all these different boxes?
It uses a data structure called the call stack. The easiest way to picture this is like a stack of plates. It works on a simple last in, first out principle. That just means the last plate you put on the stack is the very first one you take off. The last context that gets created is the first one to be finished and removed. So let's watch this principle in action with this example. We've got three functions all nested. First calls second, and second calls third. We're going to trace exactly how the call stack handles them when we kick the whole thing off by calling first function.
All right, step one. The second our script starts to run, the engine creates the very first context, the foundation for everything else, the global execution context, or GEC. And this gets pushed right onto the bottom of our empty stack.
Okay, next, the line first gets executed. This triggers the creation of a brand new context, a function execution context, or FEC, just for the first function, and it gets pushed right on top of the GEC.
So now we're inside the first function, and it immediately calls second function. What happens? You probably guessed it. A brand new function execution context for second is created and pushed onto the very top of the stack. It's getting taller.
And here's where that last in, first out principle really comes to life. Inside second, third gets called.
its FEC is pushed on top. Now third does its one job. It logs done to the console, and then it's finished. The second it's done, its context is popped right off the top of the stack. And from there, the whole stack just unwinds itself. Control goes back to second, it finishes, and its context is popped off. Then control goes back to first, it finishes, and it gets popped off. This whole process continues until only the original global execution context is left, which is finally removed when the entire script is complete.
So we've seen these two main types of contexts. This slide gives a quick breakdown of the key differences. The global one is created only once, but a function context, that's created for every single function call. The global context also creates the global window object in browsers, while a function context creates a special arguments object. And of course, the this keyword behaves differently in each, which is a whole topic in itself.
So why does any of this matter? Why go through all this? Because having this mental model, this picture in your head of execution context and the call stack, it's the absolute foundation. It's what makes some of JavaScript's trickiest concepts, like scope, closures, and the this keyword, finally start to click.
And that really brings us to the final takeaway. Now that you can actually visualize how the JavaScript engine thinks, how it organizes its work, how is that going to change the way you approach writing, and maybe even more importantly, debugging your own code?